Thank you again for joining me in this part of the video, this part of the demonstration I want to do for the Minolta. I keep saying Minolta, but I'm told that I have to say KonicaMinolta because that's the name of the company now, KonicaMinolta. With this instrument, I can measure, I can use other software than Minolta supply the FD-7 SW utility that I demonstrated before, which allows capturing the data to the clipboard and to any application. And I demonstrated how to capture it into Excel. So now I want to show you this application made by basICColor in Germany. It's a very nice application. It supports a bunch of instruments. I heartily or warmly recommend it. Over here it supports the FD-7 and the FD-9 and Spectral Dance and i1 Pro and a bunch of other instruments out of the box. And over here what I've done is I've created a template for measuring a P2P51 with my FD-7. And over here this is a new job. A job created, so I'm going to double click here and up come this window, and the first thing that it's going to prompt me to do, of course, is to calibrate the instrument. So let me get my calibration plate out of the bag, place it on my desk, and then place the instrument on it and see if I can satisfy the application. So now I'm waiting because the application is calibrating. So once I've done calibration, you see I get this message that calibration was successful. Now there's two ways I could go about measuring this chart here. There's a bunch of them. There's 25 rows. I can capture it in patch mode, in which case I can place the cursor like that, select one particular patch, put the instrument right on top of the patch like I've done in the past, and then measure away. This is one, and you see I hear a nice beep from the application that at the same time it's like a confirmation. Another one, a third one, and a fourth one, and a fifth one, and so on. Okay, I'm not going to bother reading them all because it's going to take a while, but you see there's a few other things that I can do, like add my name here, or I'd add some other kind of comment that like this was measured in patch mode and so on and so forth. And I'm going to, can I also visualize the spectral data? So this allows visualizing the spectral data. It's not very bright here. If I select another patch, it's not showing me the latest patch. Yeah, this is one of them. Oh, because it's keep going back and measuring. So I should have leave this window open, but I won't. So I'm gonna get out of this mode, get out of this job and not save it. Don't change any of the data. Is that what's written on the screen? Discard, change, and exit. Yes, that's what I want to do. So now I'm going to just open this file like that. And when I open it, you see the way it works, the application, it will lump. I'm going to cancel here, and it shows measurements. So I'm going to hit the 001, and now it shows you the measurements right next to the expected measurements. So for instance, here's the yellow. If I double click on the yellow, it wants to measure, and it will be measuring off the instrument. That's not what I want. Is there an undo here? No, there's no undo. I guess I'd have to leave the job, but I'm not sure it's going to save. Discard and save. So so let me reopen it back. I could have just double click on it and reselect set number 1, and it's going to prompt me again to calibrate. So this is number 1. So let's see what interesting things here you get on top of the base measurements. You get in this application, in this window, you see you get something called the Cmyk. This is the Cmyk value of this particular patch. It's 0 cyan, 0 magenta, 100 yellow, and 0 black. And it's patch ID 63. Column C13 makes sense. This is the XYZ, capital XYZ numbers. And what I can tell you is that 69.7 is a fraction of 100. It's always a fraction of 100. All these XYZ data are normalized either to 0 to 1 or 0 to 100, and the X and the Y numbers are allowed to vary, float on top of Y100 of 100 value. And the C lab here is 86.8, 6.8 minus 4, 94.6. It's very close to the Grackle number target. I think it's 92 or 94, one of these two. The L here in LAB can go up to 100. It ranges from 0 to 100, and underneath here I have status densities. The densities that would interest me is the letter T. In Europe they're using different density status, but that's because there's something business with the polarization filter, and they get a very different number because it allows them to measure the ink wet. But all kinds of discussions on that. I'm not going to get into that. And this is the spectral power distribution for this color. So any color that I select, basICColor is going to show me the spectral power distribution. I think it's a very neat feature because it allows better visualizing the data. Another thing that also allows better visualizing this data in this application is something called 3D analysis. And this is a very nice feature because if you move this around, you can see, you can visualize, I can visualize the LAB axis, and I can visualize the color inside this space. And the LAB axis, you see this horizontal axis is the A axis, and the other axis over here, this axis, now I won't be able to show you, but it goes from blue to yellow. That's the B axis. And sure enough, these are all measured, and I can click the points, which is a very nice feature as well. I can click the point. I can probably scale the graph a little bit if I hold the Control and Shift key, and now it makes more sense. And if I select here, this is about, no, it doesn't show me. Yes, it does show me. Yeah, 40 to yellow, 50 yellow, 60 yellow, and all the way to 100 yellow. So 100 yellow is this value. I don't know what the CMP stands for, but the important thing is that this is the yellow ramp, it's called. Over here we have the magenta ramp, and you see it's not a straight line. This is a nice feature of this application because it allows visualizing this graphic representation. The cyan ramp is pretty linear in the sense that it doesn't curve anywhere, and it is, yeah, it's going in this direction. This is the green ramp made up of cyan, tints of cyan and yellow, and this is the red ramp made up of tints of magenta and yellow, and this is the blue ramp. The blue ramp goes all the way to the bottom. This is made up of intensities or screens of both magenta and cyan. And over here what we see in the center, because I don't have a way to turn off the cyan, magenta, yellow, we would be able to see just the dots in the center. The dots in the center which represent these samples. And of course that column over here which is in the center. But you see the way it's done? It's like a square. You have a number of variations on a theme, like and you can see them clearly. There's 1, 2, 3, 4, 5, 6, and I think there's a 7th one. And what the software does for calculating the G7 curves is it will find the best value inside these grays according to the sample that would give the closest calibration to G7 methodology. And at this point, I think in the application I can switch measurement conditions from M0 to M1, and the numbers would be reflected differently here. See, this is the M1 number, 86 minus 4, 94.7. And if I was to switch to M0, would I get a different number? Well, it doesn't look different to me at this point. Maybe because there is no difference between the two numbers. It's something we have to keep in mind. Something also with the paper. The paper, you see, is very yellowed. It has a B star of 1.16. If I switch over to M1, I don't think it's going to make a difference at all. Let's see. Not even. Let's go to something crazy like D65. You see, everything has changed. And if I go to F2, everything is changing again. So it's a nice feature of this application that it's showing us some kind of previewing of the effect of the illumination on the color of the patch. So I'm going to leave it here. I may follow up with a demonstration with the ruler, but I'll see what I can do. Thank you so much for your attention.